revise the colligative properties, which are very important for board exams and of course for every exam. So one question is going to be there from this part. Okay, so we already know the Raoult law statement. The relative lowering of Weber pressure is equals to the mole fraction of the solute. So this is the mathematical representation of that same line. So relative lowering of Weber pressure means P naught A minus PA divided by P naught A. This is equals to chi B. Chi B means mole fraction of the solute. B represents solute, A represents solvent. So chi B can also be written as number of moles of solute divided by total moles, Na plus Nb. Now, one thing that you have to remember for always is colligative properties are defined for dilute solutions only. Means we mainly study colligative properties for dilute solution. So what does it mean? Dilute solution means of solute are much less than number of moles of solvent. Fine. So it means we can neglect this Nb here in denominator. So I can write the same expression again. So this will be P naught A minus Pa divided by P naught A is equals to, now I will write this Nb and I will eliminate this value Nb. So I will write directly Na. Nb means number of moles of solute. So it can be written as Wb by Mb means weight of solute divided by molar mass of solute. Na can be written as weight of solvent divided by molar mass of solvent. So it can be written as Wb into Ma divided by Mb into Wa. Okay, so which is equals to, of course, P naught A minus Pa divided by P naught. Okay, so this is the expression that we have. But in every colligative property, the purpose of using a colligative property is to determine the molar mass of the solute. That means we should be able to get the molar mass of solute. That means Mb. So when we rearrange this equation with respect to Mb, we get the final expression as P naught A by P naught A minus P. The Pa you can write here. Then into Wb into Ma divided by Wa. So this is the formula that we have to use for relative lowering of vapor pressure. Again, one thing that you can relate from here, from this equation is what, and this is the common phenomena, means a common observation you will have in all the four properties is your this molar mass Mb, this one Mb relates to inversely, means Mb and colligative properties, these are inversely proportional. So colligative property is inversely proportional to what? Molar mass of solute, of course. So this is the common observation in every case that you will have. All right, so now if I begin with the second colligative property, that is second colligative property that we have is elevation in boiling point. Elevation in boiling point. Okay, so for this the expression that we have is we write delta Tb means elevation in boiling point is equals to Kb into M, where M is what? Molality. Okay, so again this Kb is very important. Kb is very important, and this is called ebullioscopic constant, or we can write it as molar elevation constant, and its unit is very important for multiple choice questions. So unit of Kb or Kf is Kelvin kilogram per mole. This question is asked in multiple choice. Okay, so again I will write from the same equation. So I have delta Tb is equals to Kb into M. One more thing that you can derive means how would you define Kb? What is Kb? So when molality, that means when this M becomes 1, when molality is 1, so at that moment delta Tb is equals to Kb. So basically you can define this Kb or Tb. So what is Kb? Molar elevation constant. Then it can be defined as elevation in boiling point, means this will becomes to elevation in boiling point. So molar elevation constant may be defined as the elevation in boiling point when the molality is 1. Molality is 1 means when 1 mole of a non-volatile solute is dissolved in 1 kilogram of the solvent. So you can also write this definition of Kb from this formula. Okay, fine. So again, if I write the expression for m, so this will be delta TB is equals to KB into m. M is what? Molality. Molality is written as number of, means weight of solvent, by mb into for solution part we write mass of solvent in kg. So you have to divide it by 1000, so 1000 will go in numerator. Okay, so it will be again the formula will be delta TB is equals to KB into WB into 1000 divided by MB into WA. So I told you earlier also, again you can observe the same thing. What? This is the colligative property. So colligative property again varies inversely with molar mass of the solute. So this is the common observation. Now the purpose of using colligative property is to determine the molar mass. So you can also write this expression with respect to MB. So this will be KB into WB into 1000 divided by, at the place of MB we will have delta TB into WA. So this is the formula that we have. So basically you don't need to memorize anything. You can just derive this expression within 2 or 3 minutes during your exam. Okay. So again, with respect to KB means molar elevation constant, you have to use KB. If we have third colligative property, depression in freezing point. So basically you just have to change these numbers, nothing else. So for, if I write for that depression in freezing point, then for this again we have the same expression, delta TF is equals to KF into M. So using the same expression I can write directly from this formula. MB is equals to, at the place of KB we will have KF into WB into 1000. At the place of delta TB we will have delta TF into WA, same formula, no change. So basically if you are able to derive one formula, you can write other one also. And the last colligative property that we have is osmotic pressure. Osmosis is very important topic. Osmotic pressure, that is pi. Okay, so we have read the same equation like PV is equals to nRT. So we write the same expression, pi is equals to N by VRT, that means CRT, where C is the concentration. Again, this CRT can be represented as, since it is a concentration, so we can write as number of moles by V into R into T. Okay. Again, at the place of number of mole, we can write WB by MB. So it will be pi is equals to WB into R into T and WB by MB. So this will be MB into B. Okay. So this is the expression for osmotic pressure we have. Again, you can observe the same conclusion. This is the colligative property. It varies inversely with molar mass of the solute. Okay. So again, the purpose of using any colligative property is to determine molar mass. So with respect to molar mass, we can also write it as WB into R into T divided by pi into V. So this is the formula for colligative property. Okay. But one more thing that you have to remember, this method is especially used for macromolecules. Macromolecules means molecules with very high molar mass, roughly more than 10,000, like we have proteins, biomolecules. This method is used for them. Okay, thank you.